Hello, and welcome back to another Spindle TV exclusive class. How's everybody doing? I hope you all had a good 4th of July. I let y'all down on 4th of July. I did not get that Liberty Bell file out and done. And unfortunately, I do apologize about that. I actually fell ill and got sick over the holiday. And I couldn't do much of anything. So I apologize for letting y'all down on that one. I'll see if I can get that file out just so y'all have it. But I did not make it in time. All right, let's see here. I've got joining me tonight a brick wall, which is JR. How you doing, JR? And Matt.
That's interesting.
Yeah.
Reminds me of not a cat.
That's a green screen. Let me see. I don't know if I can. You'll have to turn that off on your side. I have been trying to balance a couple of things. One, I've been trying to get well. I was just down and out. I've gotten better. Not moving around I'm not jumping and skipping around as much as I thought, or much as I should be. But I'm also getting stuff done. You guys and girls, if you were in Facebook, if you're on our Facebook group, you saw the post I put out of the jig and stuff, trying to get some production things going. And so that's moving along. JR, are you able to figure? There you go.
There I go.
Eric,
he's kind of there. He's a ghost.
At least half of me.
Right. The looking good. The class tonight I had mentioned this earlier on. I had kind of showed y'all the lock miter joint and the possibility of making one of those with just a variety of 3 different tools and things, and asked the question or posed the question about doing tool-based, tool paths or profiles or carvings based on the profiles of bits that they used. Some of the tools and things, I really like Magnate brand tools. They're a decent, really good company, and they have gone above and beyond when it comes to their router bit profiles. They've drawn them all out for people, and they provide a file for everyone. And I've got quite a few of their bits. I have their bowl and tray bit. I have one of their rope twist bits. I have one of their barley twist bits of different. I have a couple of these of different sizes. And engraving bits, which are basically V bits with flat tips and things, and OG bits and things. Let's see if we can get things to focus. Camera, focus. But these router bits and everything, they get, rather than creating a 3D toolpath or having to create a 3D model. It's easy for me to just draw a line, run a 2D toolpath like a profile cut, using that special profile bit to perform the cut. And we're going to see how we can add these form tools to the tool database, and then how we could use them to make different types of carvings and cuts and things. So that's going to be it'll be an interesting little class. While we're getting at it, in the chat, just a yes or no, I guess, would be a good way to. I don't know if there's a way to raise your hand, but simple yes or no. But how many of you have ever heard of conversational machining? Conversational CAM, it's also referred to, versus CAD CAM machining, which is what we do with the Vectric software. It's a CAD CAM software. How many of you have ever heard or used conversational software or conversational machining? that's somewhat similar. It's not the same of what we're doing in ITER, what we're talking about, but it's that same simplicity, and we'll talk more about that and we'll get more involved. So no, nope. Okay. Let's see here. Give me just a second. Stand by. Let's see if I can kind of find um, with me just a second. I'm trying to pull up a reference. Okay. I'm going to go big for a second. Jared, we lost JR. He'll be back, I'm sure. But I'm going to go big for just a second. Matt, we'll see in just a little bit. Large here. And okay, back. Hey, JR, how you doing? Okay. I'm going to switch back to the large screen for a second. All right. Let me just really quickly introduce you to conversational machining. Conversational machining is also called shop floor machining. And basically, it is a software or a method that you answer a few simple parameter questions. And it's a little blurry. So if you're seeing it, you're not seeing it at all. You're seeing me. Hold on a second. Let me it would help if I switched over to the right screen for you. We're on screen 2, and let me get myself down in the bottom left corner here. Give me just a second. One. Okay. So conversational milling or conversational turning, you will typically see this on, in manufacturing, especially metal milling, manufacturing and things like that. You'll see it a little bit more than you will in woodworking for the most part, because if a machinist or something is out on the shop floor and he or she needs to go out and they need to do a simple pocket cut or a profile cut or a threading operation or do a chamfer cut or something, rather than doing CAD, the main part, CAD, computer aided design, where you have to create the design, create the profiles or tool paths and things. The conversational CAM is basically, it's kind of like a questionnaire, if you will. It asks you questions as far as like the diameter of the tool, the location. Like if I was going down a spindle, I need to go 4 inches down. I need my Z to drop a 1/2 inch. And the tool that I'm using is a 1/4 inch end mill or a 60-degree V-bit or whatever it is. I answer a few simple questions. And once those questions are answered, then it generates the G code. It creates the G code and it forms that operation. So when it comes to a spindle, if you will, in Vectric, we do what's called wrapped carving. We take a model, 3D model or a design, and we wrap it 360 degrees. And we end up creating a 3D rough or 3D finish tool path or other tool paths, V carving tool path and all, but it's on a wrap design. Where with conversational carving and everything, Let's say that I wanted to do a series of flutes on a spindle and things. I just have to tell conversational cam where my flute is going to start, where my flute is going to end, and then how many degrees my spindle needs to turn, or how far my spindle needs to turn for every slot. So it's going to run from point A to point B. It's going to raise up and return to point A. I'm going to turn 45 degrees. It's going to go down and carve. And it's just going to run that simple path. And my fluting could be an OG bit. It could be a V bit. It could be a round over bit. It could be just an end mill, right? Whatever. It could be a box core bit. But that tool is just doing the cut, and it's doing it in more of a 2D type method versus a 3D type method. And it makes run times much, much quicker. And with conversational cam, depending on what there's conversational cam for milling, and there's conversational cam for turning, which is like spindle type turning and stuff. And when we're using router bit based tool pathing or design profiling and stuff, in a way it's kind of like what we're doing. It's kind of conversational. It's not exactly the same, but if you have a production type environment, then rather than having CAD CAM design, conversational CAM is absolutely a software that one should have and be able to use and operate to create simple toolpaths to make production quicker. Run times that would take hours if on a wrapped project only takes minutes, with a conversational machine project and stuff. So Kipware, it's a company that I just reached out to today. I love their conversational software. I really like it and everything. It's a company that I'm going to start a relationship with Digital Woodcarver. I think if everything works out, I'm going to be using a trial of their software starting tomorrow. And I'm going to be testing it with our machines and seeing if it's a good relationship to offer to our customers along with the Vectric software, because there's a place for CAD CAM design and there's an absolute place for conversational CAM machining as well too. And if you've never experienced conversational CAM, you're missing out on a lot. There's a big disconnect there, and it's mostly your industries type that use that type of machining methods and all, but it's absolutely phenomenal. Okay, so that's kind of an introduction on that. Now, what we're doing is very similar to, let's call it, it's more of a conversational method than it is, bear with me just a second.
So it's more like a more advanced, but not as advanced parametric.
Yeah, so anybody off the street can walk in and run a conversational program with absolutely no CNC milling experience whatsoever. All you have to do is be able to answer a few questions. So at what dimension or distance does this operation start? Where does it end? What size is the router bit? How deep is the bit need to drop? That kind of thing. And so if you were to, as far as the definition of conversational programming, it is conversational programming is a tool that allows the machine's operator to create programs for CNC machines without needing specialized programming language knowledge. Conversational program uses prompts, those questions and answers, to guide the operator through the machining process. And then the machine can automatically, once those questions, like dimensions here and there are answered, then it writes the G-code, very simple G-code to go do what needs to be done. It's typically used for simple or common machining operations such as drilling, tapping, and profiling. The operator can input certain parameters such as the dimensions of the workpiece, the type of tool being used, and the desired depth of cut, and then it writes the G-code and does the rest, based on those parameters that were answered. Very, very simplistic, carving methods and all. Now, imagine, if you will, that the spindle that you see on the screen here, imagine that I'm making this as a three-dimensional model, right? So I have my profile, and I go into my modeling tools and I wrap and create this design, this profile here. Now, for my tapered ball nose bit, my 3D rough, my 1/4 inch end mill to do the 3D rough cut, and then my tapered ball nose bit to do the finish cut. So that part is, you know, either moving around or my bit is moving back and forth in a raster position. You know, my 1/8 inch tapered ball nose, my 1/4 inch tapered ball nose, whatever it is, you know, as it's going and milling that profile, that based on my step over, that spindle is turning as that bit is kind of traveling back and forth at that 8% step over, whatever it is, to do that 3D cut, versus my router bit just moving over to a line or path that I would have. Let's say, for instance, that on my drawing, I've got a line drawn here. Let's space that over and let me get that line centered. And let me get this bit centered. So I have a line and I have a profile cutting on the line, and I need the bit to cut down, you know, let's see here, 0.89 inches deep. That's how tall this profile is here. My bit is going to travel over to that line. It's going to, you know, drop down. It'll do it in steps, or you can do it in one pass or what have you, but it's going to drop down. And then that spindle, the y-axis, if you will, is going to make one 360-degree turn. And that 360-degree turn is going to turn that profile into the spindle, or in, if it was a panel, if it was flat, you know, let's say I'm making raised panels, I'm following that rectangle with that profiled router bit to cut out that profile. And so depending on the router bit being used, that bit can come in and it can drop down. And again, it could do multiple passes and everything, but by the time it gets to its final pass, and that spindle is just making a simple 360-degree rotation at, you know, whatever, 100 inches a minute, it's just going to go around. And then by the time it goes 360 degrees around, that router bit has cut that profile in that spindle. And so depending on, like, if I look at Magnate's tool database, they have drawn all of their profiles out. And you can simply add these tools to your tool database very easily. So let me do that right now. I'm going to go into node editing and cut this in half. And I'm going to take this right half of this toolpath, and I'm going to join that together as one. Now, Magnate, when they made their profiles, it's all different. You know, this arc is different from this flat depth, is different from this arc, this flat depth, and so on and so forth. So here I need the right half of this profile, and then I can go in, and this is the classic plunge. It's got a 3/4 inch cutting diameter. I can go into my tool database, make sure that pops up on y'all's screen. And in here, I can add a new, I have that profile selected, of course, that half of that profile selected before I bring in the tool database here. But I can come in and add what's called a form tool. So when I do that, the software automatically draws the left side of that bit, completing that profile. And then all I have to do is go in and set the parameters. Once I set the parameters and everything, now that tool is added to the tool database, and I can absolutely go in and let's go ahead and close. Let me, bear with me a second. I stretched my tool database for some odd reason, but I can go ahead and click apply and OK. And in Vectric now, I could come in and I'll just do a very simple line right here, which is already there. I don't know why I'm trying to draw another one. And on that line, I will do a profile cut. I'm going to cut the depth of that particular bit that I just added, which the total cut depth, let me get back to it here. That total cut depth was 3/4 inch in diameter, and the total height is 0.3301. So from the very tip of the bit up until the right at the top of that profile, 0.3301. So that's going to be my depth of cut. Let's say 0.3301. I'm going to cut on the line, and I'm going to choose that bit. When I calculate that tool path, it would help if I selected the right vector. Hold on a second. Your goofy instructor selected the profile vector. So on here now, let's turn this. I can simply run that toolpath to cut that profile, and the that toolpath to cut that profile, the estimated run time on that is, less than 15 seconds, right? For it to do that. That's on my big machine. If I was on my smaller machine, about 17 seconds, right? So using that profiled router bit, let me turn off these here. All I have to do is in Vectric, all I have to do is draw the lines, the paths that I need my router bit to follow. And I'm either creating a profile toolpath, a pocket toolpath, or whatever it might be, drilling toolpath, depending on what it is that I'm doing. So it allows for parts to be machined very quickly. Now, I work with Digital Woodcarver, as you all know. One of our competitors is Legacy Woodworking, and they have machines like the Maverick and things like that. And they have a program that's their proprietary software called Conversational Cam Pro. Now, when Legacy are teaching their classes and everything to their customers and stuff, let's say they're making a spindle or a table leg, and let's say that part of this table leg, one section of this table leg, has a 3D model carving on it, a grapevine or whatever it might be. Now, that part of the leg between those two vectors where this model is, they're going to use, and they're going to create the toolpath, the 3D carving toolpath in Vectric. They'll use Vectric for that. And with Vectric, they're going to have the selected vectors as the boundary. And when they calculate the toolpath, that bit's going to come over and it's going to run that 3D carving of that grapevine on that section of the leg, whatever it may be. Now, the rest of the leg that has, it could have some type of cove or dish or chamfer or bulge or whatever, they're going to take that simple operation over to their Conversational Cam Pro program. And they're going to, based on their spindle's length and diameter and everything, they're going to, enter in the parameters, where the dimension, where it starts, where the spindle needs to be at 0 degrees or 45 degrees or 90 degrees or whatever the case may be. And they're going to where it starts, where it ends, and how deep the bit needs to travel, right? So if you use simple parameters, and it'll create the G-code for that. So after they get done with their 3D model carving, when it goes and picks up the next tool, or they do a manual tool change or whatever, when they run that next G-code, it's just the bit going to go over, it's going to drop down, and it's either going to move, or that spindle is going to turn one full rotation, the bit's going to come up and go back home, whatever the case may be. But they're using a combination of both conversational machining and CAD/CAM machining, because they're doing production, and run times are important. Production times need to be low, small, so profits are high, right? So that, if they had to do the whole table leg in Vectric, let's say all the wrapped and everything and all, it could take hours, 7 hours, 6 hours, 5 hours, whatever. to do the whole leg, when really in realistic, in reality, it might really only take 30 minutes to do that grapevine area, while it takes another 15 minutes to do the rest of the leg. And if you're ever curious, check out, on YouTube, check out, Legacy CNC, and just listen to a couple of their little classes and stuff they do, and all how they use the conversational cam. It's phenomenal, right? And with me, with Digital Woodcarver, we have a 4th axis as well. We have our flat table and all, and I use conversational milling when it comes, but I do it in Vectric, so it's not technically conversational milling. I'm not answering things. I'm still using the CAD, the design side of things. I'm still drawing the rectangle and all that stuff, but it's very similar. Now, when I start working with the Kipware software, then that's going to be true conversational milling, where I just have to answer a few things, and then my bit's going to go where it's got to go. My spindle's going to turn, or whatever is going to happen is going to happen. It's going to be just quick and easy. So in Vectric, let's go in and set up another sheet here. So I'm going to add another sheet, and this sheet is going to be a 24-inch tall. I'm going to call this my panel door. What went? Let's try that again. Let me turn my cap locks off. That's what happened. Panel door. And on that panel door, I'm going to go edit that sheet. And that door is going to be 24 inches tall. That's the width, Laney, you goofball. It's going to be 14 inches wide and 24 inches tall. 24. And 3/4 inches thick. Now, in here, I'm going to take and draw a rectangle. I want to be on my panel here. I want to be 1 inch, 1.5 inch in, like a door frame, if you will. So I'm going to take my x-axis, and I'm going to do it from the center. So x divided by 2 equals, that'll give me the center of the width, and then y divided by 2 equals, that'll give me my center point. And then I'm going to take my x and I'm going to subtract 1.5 inches from that. Actually, it's going to be 3 inches, 1.5 inches on both sides. So x minus 3 equals, and then y minus 3 equals, and I'm going to create that 1.5 inch border there. And then from here, if I have multiple bits that are going to create one profile, or one, design and everything, then I'm going to create all of the, the profiles that I need to create. If let's say that here on this profile right at the edge here, I'm going to create a tool path. It'll be a profile cut. I'm going to go, let me select the tool first so I can know which tool I'm grabbing. I'm going to go down to my form tools, and I'm going to have a OG bit that is 1/2 inch deep. And so my cut depth is going to be 0.5. I'm going to be cutting on the line. And when I calculate, well, let's select the vector first there, Laney boy. Let's close that tool and calculate. When I carve that toolpath, my bit is just following that one rectangle to create that, that raised panel design, for the door and all. So that one bit, just follows there. Now, the thing about that is, in this particular instance, because the bit is following that simple profile, I get rounded corners, right? I get rounded corners here. So for the most part, there's in that profile cut, there's no way for me to, there's no real way for me to select my sharp external corners and things unless I'm carving on the outside of the line. Then I can have external sharp corners. So if I'm carving on the outside of the line, my bit diameter is 1.25 inches. I need to account for that, right? So if I'm accounting for that, then imagine, if you will, 1.25. Let me drop that in here. My normal tool path would have had that bit carving on the line, right? The profile toolpath that I just created was on the line. So it created the rounded corners and all. Well, if I'm going to be creating on the outside of the line or the inside of the line, whatever the case may be, then I need to kind of account for, that offset allowance if, in fact, I do need the center of my bit cutting here, kind of thing. In this case, I'll just use the I'll cut on the outside or the inside of the line with this bit, and I'll use the same bit. We'll calculate, oops, hold on a second. We'll calculate that tool path, reset the preview, and then preview that visible tool path. And again, it's not going to give me those sharp corners. Now, on the external corners here, on this area here, I have a nice miter cut, but not out here where it kind of counts for me, where it matters and stuff. So I can't just, I can't just tell the toolpath to come and cut and then, come and cut, because no matter what, my bit is round, no matter how you slice and dice it. So we have in CAD CAM design, we have tool paths such as the molding tool path. Let me get over here. And on the molding tool path, it allows me to do sharp corners, but I'm having to use, like a ball nose bit to kind of do it. It kind of creates that 3D cut, if you will. I can't use a single bit to do it. So there are some limitations and stuff that, to what I'm, wanting to do, especially if I'm doing an internal cut like this, where, we have to go, in. And in this case, it might be a matter of where I use a combination of bits, to where in here I will use a end mill to, possibly come in and, create that sharp corner, or even a V bit, a V carve type tool path to come in and create that sharp corner. And so if I tried that, let's say that, I don't know how this is going to look, but let's say that I offset if I come in and offset outward 1/16 of an inch with sharp corners, and I won't do the round corners later, we're trying to prevent that. Offset square corners and everything. And I come in and do a V-carve toolpath, and I'll use a 90-degree V-bit for this. And I'll calculate that toolpath. Now, I don't even know what I set. Let me see what I set the depth at. That would help. There was no flat depth, so it's only going to carve as deep as those two lines are spaced, so that's fine. If I preview that visible toolpath, again, I don't know what this is going to look like, but let me turn this around. Yeah, so that cut here, but again, it didn't remove this area here. So it's going to be a combination of other bits, you know, trying to clean that up. And we don't want to do that. We're not trying to do that. We're trying to, you know, just use bits and just create a, you know, a simple profile toolpath. But where we can't, we can't. You know, we use the other. That's why there is CAD CAM. That's why it exists. But when it comes to, if I'm not doing an internal cut or something like that, and I'm just doing something such as a, well, we'll get to the route. We'll get to the miter cut in a moment. We're doing something, let's say on my panel door here. We're going to create our rectangle still, and then I'm going to create a series of lines, one from here to here. I'm going to hold down, I'll just do this. We'll do an array of 1 row, 15 columns with a distance in between each column of 1/4 inch. Now let's go 3/8. Okay. And let's go Brandon. All right, let's take these two and get rid of them. Let's select the rest of these. Hold down the shift key, select the outside rectangle, go to the alignment tool and align to the center. Not like that, you goofball. Select those. G for group. Select that rectangle and then align to center. All right. So let's say that on my outside cut here, I'm going to have a 60-degree V-bit that has a 1/4 inch diameter. So I want to offset inward 0.125. And then I want these flutes to actually start there and end there. Now these profile flutes are going to use a bead bit. So we'll go profile cut on the line. I'm going to first, there's going to be a pocket that's going to be 1/8 inch deep. So I'm going to start at 1/8 inch. I'm going to cut down another 1/4 inch from there, and I'll use my beading bit. Let's see. That one. Yeah, it's going to be that one. Apply. Select. I'm going to come in here and calculate that. I'm going to select this vector and do a pocket cut that is 1/8 inch deep. And if it was for production purposes and things, I would use a combination of bits. I would use a 1/2 inch end mill as well as a 1/4 inch. Calculate that. And then here we're going to do a 60. We're going to do a profile cut. We're going to cut down 1/8 of an inch with a 60-degree V-bit. 1/4 inch diameter. And this is going to cut on the outside or inside of the line, sorry. And calculate that. Okay, so if we look at our first cut, we'll have the V carve or the V bit that kind of does that edge there. We have our pocket cut that's going to remove the material in, and I need to go a little bit on that pocket cut. I need to have the end mill go over the line just a little bit further. And then the beading bit is going to, oh wait, hold on. Preview the visible toolpath. Sorry, I had 2 bits. Preview the visible toolpath. Get rid of that. Okay, and then I need that end mill to come over just a little bit. So I need to do what's called an allowance offset. And pocket allowance, we're going to go negative 0.0625. Okay, and on this particular one, on my corners, I'll have to take a little bitty chisel and get rid of that little bitty piece right there and everything. But now on my profile cut here, my bit is a 1/2 inch in diameter. So I got to keep that in mind. It's going to cut into this edge. So let me really quickly fix that, because my bit is 0.499, so a 1/2 inch in diameter. So let me draw a 1/2 inch diameter bit here. And I need that bit to stop here. And since the tool paths run from center bit to center bit, you know, the paths from center to center, then my profiles, I'm going to hold the shift key down so it does both sides at the same time, but I need them to go to the center of this, and I believe I hit the center. Oh, just a little off. Now I'm grabbing it in the middle so I can move this up and down. But I'm moving my mouse over to this vector so that I can, you know, kind of snap to the point or what have you. And by holding the shift key down, it did that same movement on both ends. Okay, so now we're going to go, let me see if I did my beading right. That bit is, the point of the bit is going to cut down the middle. And right at the center of that arc, it's supposed to be kind of a nice curve there. It should be, because they're overlapping at the right spot. Let me find out if it's not, but then I just adjust the spacing of my lines accordingly. So on this profile cut, let's select those vectors and calculate, and then preview that visible toolpath. And I've got a peak there instead of a rounded curve. So my bit, the spacing of my lines is too close together. So I'm not right at that nice curve. So I need to space them apart a little bit more. Let's undo the last. Go back into here. And let's take a look at my profile of my bit again. The rounded over edge here, if this bit is a 1/2 inch, so this is a 1/4 inch to this point. And that I'm cutting on the line. So my spacing, my next line has to, if this is going to step over, this is a 1/4 inch distance. I need it to step over a 1/2 inch, or maybe slightly less, so it kind of meets in the middle. But right now they're only stepping over a 1/4 inch. I was off by a whole 1/4. So let's take, and on these vector lines, which means I'm not going to have as many beads. I use a smaller diameter bit if I had one, but I don't have one programmed in my tool database just yet. But let's get rid of these lines. And on my step over, I need, instead of the 3/8 of an inch gap, I need a 1/2 inch, but I want to be just a little under 1/2 inch. So 0.49. Yeah, 49. We'll just leave it at that. Okay. Get rid of these 3. Now, very important, when that bit is cutting on this line here, I need to, kind of be, somewhat evenly spaced here. So if I were to take these vectors and to align them to the center of this vector, or I could just align it to the center of the material since it is in fact centered. This takes me right at the inside of that pocket, and I should be just fine with that because that outside part angles outward. So I should be clearing that just well there on both sides. So if I come in and select those vectors again, same toolpath, my cut depth. Now this is important too. My tool from the bottom of the tool to the top is a 1/4 inch high. So that's what I want my cut depth to be. And that's what I've got there. So when I calculate this toolpath, I should end up with rounded beads just ever so slightly. Well, they're rounded. But I should end up with those rounded beads for that kind of beaded door look versus, creating the 3D model. Now, this particular cut here, if I were carving this with my bits and everything, estimated runtime and everything, my pocket cut is going to be the longest one. But we're looking at about 41 minutes versus a 3D model cut, which, would be, a few hours, right? Depending on, with that 1/8 inch tapered ball nose or 16th inch tapered ball nose, whatever ball nose you're using and all. So using profile based or router bit profile. When I say profile, not profile toolpath, but router bit profile based toolpaths could help us with, creating different looks, creating different styles, and reducing runtime. Now, switching over to, let's say, joinery for a minute, depending on, things that we're trying to accomplish, we can use router bits and their profiles to create different types of cuts. A combination of these, can create a different type of cut to create, different outcomes. So in this case, we have what is typically referred to as a locking miter joint. And generally, you would be using, on a router table, you would be using a lock miter bit, and you would be carving, when you're running your board on your router table, you run the board one way along the face of the cut, and then on the other board, the board that's going to be joining it, that's up on its edge, and it runs to create that kind of that lock miter cut and everything. In this case, let's say I don't have a lock miter bit, and I don't have a router table. All I have is my CNC to do whatever I need to do. Well, if we were to, take a look at this in kind of a flat aspect, which is, over here, all we would need to know is a certain amount of parameters, how deep the bit needs to go, where to draw our lines in order to make, these parts and the cuts and things. So these cuts would typically be done on the end of a workpiece. So let's say that I have a piece of material. We're looking at a side view here. I have a piece of material that is 3/4 inches thick. It is, and that's going to, in this case, that's going to be the height right here. So that's how thick we're looking at a side view. And it has a overall length. Let's say it's a picture frame. And so let's say it's got, 12 inches in length. And imagine that on two of the pieces, let's say we have, let's move one of them down here. So these are my two pieces of my frame. It's a 12 by 12 frame. Let's imagine that, right? So on one of these parts, we're going to have the tool paths that are going to come, the router bits are going to come down and make whatever cuts to remove this waste material right here. So the end of my part has that locked miter cut into it, if you will, right? So I'm going to have an end mill come and, a V-bit come and do a cut. I'm going to have an end mill come and do a pocket. I'm going to have a slot bit that's going to come down and come in and cut that slot and then back out. I'm going to have the V-bit again come down and cut a V cut. So there's a combination of tools that are being used to make that cut. And the same thing with the partner, let's say on the other end of this board, I have I create the tool paths to make this carve. And again, this is the waste area right here. So my V-bit is going to come down. I'll probably have an end mill come down first and remove this waste material. And then my V-bit's going to come and make this cut. And we'll create the tool path so you can see this. Like physically, we'll lay out the tool path for it. And then my end mill is going to come and remove this little bit of material here. It's going to come and remove this material here. And then my V-bit's going to come and take that little chamfer, right? So that way, when these parts come in and, that waste material, oops, bear with me just a second. So that way, when that, I keep losing my piece, but when the, the router bit comes and cuts that part, I now have these two parts that I can come in and, at my workbench, I can join them together to make my frame, right? And so let's actually make the tool pass based on the dimensions that we have here and based on 3 different router bits. So we're going to be using the Amana 45700 bit. Let me pull up the parameters of that bit. Amana tool 45700. All right. So in this particular bit, the diameter of this bit is 3/8 of an inch wide. It's a 90-degree V bit. The height from the tip of the bit to the top of the cutter is 7/16 of an inch. From the tip of the bit to the top of the cutter is 7/16 of an inch. And then from the tip of the bit to the top of the V cut there, that is 1/4. Let me see here. 3/16. That is 3/16 of an inch height. And so I get all the parameters of that router bit. I get all that information kind of here. So now I know kind of the diameter and the cut of my bit, right? My, my jib. The same thing with the Magnate 6124. I can go to magnate.com, magnate.net, not .com. They've kicked my butt. Sorry, Magnate. And shout out to Magnate. But their tool, what was that tool number? 6124. 6124. This T-slot bit has a kerf height of 1/4 of an inch. It has a large diameter of 1 3/16. It has a small diameter, that neck area, of 3/8, shank diameter 1/2 inch, and then the cutting length from the bottom of the bit all the way to the top of the neck is 5/8. Right. So I got the parameters. Now I know what that bit is. Right. And I've got that programmed in, my tool database and stuff. And a tool database can't do undercuts and everything. So literally the only thing that I have on in the tool database, it's set up like an end mill with the width here up to the sides, because we only draw the right half of the profile. If I draw this coming in and up, Vectric won't take it, right? So I only have the diameter. So Vectric's not going to show me a cool slot, and everything. And then of course my 1/4 inch end mill is a 1/4 inch end mill, right? So now having those 3 bits, let's create a piece of material. And I'm going to make a new sheet. This is going to be my frame parts, if you will. I'm going to have, I can do a profile cut to cut the parts out and stuff. So I'll go 14 inches. That'll be fine. 14 inches wide. On the height, they're only going to be, my frame pieces are only going to be, let's say 1 inch wide, and I only need 4 of them. So let's say I have a 6-inch board here. Okay. All right. So I'm going to draw out the rectangles of my blanks. Let's imagine a blank with no miters cut at the end of them at all. So my blanks are going to be 12 inches in length. They're going to be 1 inch wide. And I'm going to need 6 of them. So 1, 2, 3, 4, 5. And I didn't count for the spacing between my parts on my board. So let me go back into my sheet. We'll make this a 9.5, like a 1x10 board. All right, now on here, let's take these 3, and we're going to space them equal distance. We're going to align them left to right with each other, and then we're going to center them on here. And I'm actually going to space them more than what they are right there. So I'm going to draw a line across the whole width of my board, not a crooked line, a straight line. And I'm actually going to do that spacing again, but this time I'm going to select this line here, and I'm going to do equal spacing along that line that I select last, right? So that'll spread them out and give me equal distance spacing between all of the parts. So the distance between here is the same as the distance between here, all the way across. All right, so we have that. Now, looking at my, I'm going to take and I'm going to copy these vectors over to here so I don't have to keep switching back and forth between the sheets, but I'm going to take these vectors right here and copy them to the frame part sheet because I want to use these dimensions. And I'm going to move these up to here. Okay. Now, from the end, we'll do one piece at a time, or one edge at a time, because this edge might lock into that one. We have to think about, which is going to be our 4 intersecting corners and everything. So one cut gets cut out one way and one the other. But here, the distance from the edge of the board to the inside of this cut is 0.354 inches. And so I'm going to come in and I'll just use guidelines to help me out, lay out my guidelines for right now. And then I'll draw my vectors and everything. I'll draw my vectors and stuff accordingly, just my lines, my paths and stuff. But so we need a vector line that is 0.354 inches over. And I'll answer questions. And I'm sorry, ladies and gentlemen, I'm just rambling today and I'm not even paying attention to y'all's conversation. Let me open up the conversation in front of me. Sorry, ladies and gents. We lost. Matt left. He probably got bored of listening to me without interacting. Let me get to y'all. So go here. We'll take a pause for a second. YouTube Studio. Content. Okay, let it open up the chat. Sorry about that. All right, let's go back up and let me see what all I've missed on ours conversation. Hang tight for 2 seconds, ladies and gentlemen. Let's see. Without knowing, Matt says, without knowing it, this is exactly how I designed the tooling software for the 5th axis lathe. Brooke says, Laney, you can bring a Kipware rep to a Wednesday night class. We can. Once I start a relationship with them, I'd be happy to. Good evening. Let's see here. AI generated tool pass. Possibly. I don't, there's no AI interaction right now with Vectric or anything like that. But it could be possible. Let's see here. Matt says, not really. Every piece of greenwood is different, so I have to adjust on the fly, right? I have a series of drop downs and prompts that adjust in real time. Good. So let's see. It's mainly for rotary projects. No rotary CNC is way too slow and messy. It's a true lathe. And he's got an integrated 5th axis. So yeah, so it's a true lathe with a router and all and stuff. So it's pretty cool for Matt. If you've ever seen Matt Gifford, he's not with us. He dropped out. But you ever see Matt's setup? He's got a pretty cool setup. He's got a little benchtop CNC that makes box parts, and there's a hydraulic that kicks the parts off into a little plastic bin, like a bin. Kicks it off, and another part loads itself. It carves and it kicks that one off, and he's got it all a little automated. He's got a little 5th axis head on his router for his lathe. Pretty cool stuff. Matt's into all that awesome stuff. We lost him. He left a minute ago. But anyway, so no questions. Cool. Okay. So here, once again, let's create that guideline. And let's create it. Relative 0.354. Create that. Bear with me just a second. There we go. Let's get rid of this one so it doesn't confuse anything. All right. And then from here, let's see, from here to the inside of this line where the bit's going to be cutting, that's 3/4 of an inch. So let's create that one. I'm not going to do the whole thing. I'll just do one of the miters so you can see the layout. But 0.75, create that guideline. The distance from, I need to know the distance from, get my tape measure out. From here to here, 3/16, and then from here to there, 0.6845. Okay, so let me make those two guidelines. 0.6845, and then 0.1875. Okay, so that should be everything that I need for that. Now, let's take a look at, let's come in here and let's take a look at what's going to happen so you can kind of get the general idea. Let me turn off the dimensions, hide them for a second. But the Amana 45700 bit that has a diameter of 3/8 of an inch, okay, it's going to, in a 90-degree V-bit, it's going to come down, and on the vector line, whether I cut on the inside of the line, the outside of the line, whatever the case may be, depending on where I drew my lines, this bit is going to come down on this, and it's going to just travel right across the piece. So it's going to drop down to, let me come here. It's going to drop down a distance. So my cut depth on the profile toolpath that I make is going to be a distance of, or a cut depth of 1/16 of an inch. And so with 0 being, let me turn the dimensions off again. With 0 being the top of my board, my bit is going to be coming down 1/16 of an inch to create that slight little chamfer, right? So it's going to come and just make that cut. Now, from here, I'm not going to use my V bit to do that flat work and everything. I'm going to use my end mill. Now, technically, I could use my 1/4 inch end mill, and it's just going to be doing a pocket cut, or it's going to be doing 2 passes, not a pocket cut. That would be a waste of time. It's going to be doing 2 passes. So there's going to be a center line here that's going to come and cut. And then there's going to be, imagine there's a slight step over, and then there'll be a line on this end that gets cut over, right? So that's going to cut that flat with the end mill. Now, technically, I could also use the slot cutting bit, right? It could actually come down on a line and step over a certain amount to cut that if I wanted to, but that's kind of a bit of a waste. Now, my end mill not only is going to be cutting those 2 lines there, which I need to draw. Let me do this first one. Let me get the dimensions for this first one. The distance from the end of my piece. Now I'm calling this the end of my piece, the end of this point right here. My horizontal distance from there to where the center of this bit needs to run here, that distance is 0.5625. So I need that guideline too over there. And then this distance I already have, the 0.354. So I don't need anything there. Now, turn the dimensions off. This end mill not only is going to be cutting these flat areas, running those 2 cuts there, but it's also going to be running a cut coming down and clearing out this material. So it's the end mill is going to be running and, cutting out that material. Now it's going to be, again, 0, the top of my board. The distance, let me turn the dimensions back on, from the bear with me just a second. I got 2 of the measurements, but I don't have the 3 that I need. So let me just take that measurement really quickly. So vertical from the top of the material down to here, it's 0.5625. Okay, so it's just the same width as it is height there, 0.5625. And then that's going to clear out that. Now, my T-slot bit could have done that also, right? My T-slot bit, could have come and cleared all this out. But why, why would I want it to do that? I don't know. I could, but I could come down here, but there's going to be a special move that it does. It's got to come in and cut, from underneath. So it's got to come down. It's got to move in for that carve, to cut that. I'll show you how we create that. But I'm going to have the end mill do the clearing. So all my profile bit has to do is just come down and move in, make its cut, come back out and back up. I don't have to worry about making steps. I want this to kind of be a one pass. I want this tool to be a one pass tool. I want it to be able to come down in one pass and everything. So let's go back over. To here. And let's make my one more guideline 0.5625. Okay, that's all I need for my guidelines. Now let's actually lay out the toolpaths. Let's create that guide. Okay, so I want to draw a line. I need my bits to kind of start off the part and then cut across. Okay. So I want how far I start off and how far I finish off. Let me turn these guidelines off so you can see what I'm doing here. That's going to be based on the diameter of the bit. So the end cut, and normally, just so you know, I would normally have these parts already cut. They would be clamped to the table, and my 3 bits would just be making those miter joints on the end of them. I would have had them cut on the table saw and all, but we're assuming we have no other tools but a CNC machine right now, and we have to cut them out of our board. We need to create this frame, and we've got to cut it out of this board, right? So I need to make sure that when my router bit travels, when it comes and travels across, it travels at the proper depths to make whatever cut it needs to do. So I need to draw a line on each one of these guidelines right now. So I'm going to do that, and then I'll figure out how far off it needs to start and stop. So that one, and my bit is following a simple path. No 3D modeling, no anything. Now, in conversational CAM, I would literally not be drawing this like this at all. In conversational CAM, I would just be answering questions, typing in these dimensions into boxes, and it creates the G code, and based on what it's supposed to do, based on the dimensions I type in, answering the questions. I wouldn't have to draw this out and lay this out like this. So that's where conversational CAM is a pretty cool thing. Okay, so let's get these lines centered. All right, let's actually, oh, you got to be kidding me. I'm holding the control key instead of the shift key. So hold that shift key down and it'll move the line on both sides. So when I'm sizing it down, it'll keep it centered where it's at. It'll just change both sides. Now we're going to do one toolpath at a time, and we'll preview the toolpath so you can kind of see the cut of what's going on. The only cut that's unfortunate that we're not going to be able to see is the undercut of the slot, which is kind of what really makes it look the way it is. But the first toolpath I'm going to create is a profile toolpath so we can do the cutout. So we're just looking at the one piece. So we'll do a profile toolpath, cutting 3/4 of an inch deep with a 1/4 inch end mill. On the outside of the line, and we'll calculate that toolpath. Now, what that's going to do is it's going to allow me to get rid of the waste here. So we're just looking at the end of this piece so we can see, you know, each of the cuts and everything as they happen. All right. Now, my next cut is this cut here. This is the 3/4 inch line right here. And my V bit needs to be, you know, coming in. It's going to be cutting down 3/16 of an inch, but it needs to come in this small distance here. So the center of my bit needs to be actually here, not at 3/4. Now this distance, if I were to measure that, I believe it's a 1/16 of an inch, but let me just verify that. From here to here, yeah, it's a 1/16 of an inch. So I need to create another guideline. Actually, this one doesn't need to be used. This one needs to be moved in a 1/16 of an inch. Move negative 0.0625. Okay. All right. Now, that line, we're going to do a profile cut on the line, cutting a 1/16 of an inch deep. We're going to be using a 90-degree V-bit with a 3/8 inch diameter head. We're going to calculate that. So that's going to create that small shoulder, that small chamfered shoulder. My next tool pass are going to be the 1/4 inch bit, and we're going to be on that 1/4 inch bit, the 0.6845 line, which should be this one right there. We're going to be using a profile cut. Now, depending on how I drew the line from top down. So that means my start point, where this black point is here, if I was in node editing mode, it would be a green node. That's my start point. Imagine if I was standing looking at that point. If I'm standing looking at that point, then this would be my left side. This would be my right side over here. So I need that bit to be cutting on the outside right of this line. So when I come in with that 1/4 inch end mill, and I'm cutting on the outside right of that line, the right side of the bit is going to be cutting down that line. So when I calculate that tool path, if we were to look at that's where the center of the bit is, but if I would do the full view there, I'm cutting on the inside of that line there because of my start point. So that is going to be cutting down a 1/16 of an inch. So let's go back in there, 1/16 of an inch on the outside of the line. It's going to be cutting there, but also it's going to, I want it to do this line as well, which should be my 0.354 line right there. So I want to calculate both of those. Okay. And that's going to remove those two areas. But now that might not have been my 0.354 line here. Let me find out. Let me see. .5625. That's the center line to that. And then 0.354 would have been the line before that, which is that one. Yep. Okay. So I can't, this one's got to be center of the bit on the line. It can't be coupled in with this one unless I do this on the line and I select this vector instead and this one. So that one and that one. We'll just do on the line instead of the offset. So undo that last and preview that visible toolpath, and that should give me my flat pocket there. So now I have that shoulder and that flat pocket. So again, my bit's just coming down and cutting right across, you know. All right, now I need the bit to come down that 1/4 inch end mill. I need it to come over here, cut on the right side of this line right here, and I need it to come down and remove all this material. And that cut depth, the measurement was 0.5625. So this line is going to be a profile cut, 0.5625, 1/4 inch end mill on the outside right of the line, calculate, and then that's going to come in and make those passes, clearing all of that out. Okay, wonderful. Now, this is all waste right here. This is waste. So I want my end mill to kind of come and mill that down too, you know, down to, you know, this level. So I want to have, you know, the end mill come and cut this one too. So I'm just going to have on that same tool path, not that same type of toolpath. I'm going to select this line, profile toolpath 5625, but this time I'm going to have it cut on the line. And that's going to remove the waste. Okay. Now, I wish Vectric would show the slot cut, but it's not. The slot cut is here, right? So that T slot, I'm going to show you how to, we're going to create the toolpath. I'm going to show you how to move it in to make the cut and then come back out. That's a G-code manipulation. It's not Vectric. It's not in the Vectric toolpath. We have to create the toolpath first. But if I try to preview the toolpath, it won't show the undercut. It's just going to remove all this material right here, which sucks because it kind of really shows, that miter joint. But let's do this last miter here. So this last cut, this is half the diameter of my bit, 3/16. It's 3/8 inch diameter, 90-degree V-bit. So my V-bit just needs to cut 3/4 of an inch deep on this line, right? So on this first line. So we're going to, it's going to be a profile cut. The cut depth, now I've already removed 0.5625 of this. So 0.5625. I've already removed that material with the end mill. So I can start there for that V-bit. And then I need to cut down another, I'm going down 3/4, so another 1/4 of an inch, 0.25. And then, nope, another 3/16 of an inch, 1.875. And if I'm doing my math right, 5 and 5 is 10, 7, 8, 9, 10, 14, 15, 75. Yep. Okay. So 3/16. So I'm starting at 5.625, cutting another 3/16. Now I'm going to be using my 90-degree 3/8 inch router bit or V bit. Sorry. Let me find it. Why am I losing my mind on my... Hold on a minute, ladies and gentlemen. I have misplaced. Where's my... That's my 1/2 inch bits. Where the hell did my 3/8 inch bits go? There it is. Whew. I was like, wait a minute. And it even says the number 45700. It says it right there, plain as day. All right. So we'll select that. And we're going to be cutting that bit. The center of the bit is going to actually be cutting right on that line. So on the line is exactly right. So we'll calculate that tool path. And so that will come down and cut that chamfer. Now, the only thing that we're missing in this visual is that T slot, which is right about here, unfortunately. I mean, we still got to create the toolpath, but I can't preview it because all it's going to do is remove this material. But that is the my lines and everything and my depths of cut and my step, how far over and all. That's where the positions are for my bit that just has to come in and do that cutting and everything to remove that material to create that particular miter. And again, the undercut's the only thing we can't see. But let's talk about this undercut for just a moment. Okay, it's very important. Now we're going to be using the 0.354 line. So this line right here, that's going to be the line for our toolpath. Now our profile bit, that big wide bit is going to be coming in. That T-slot bit is going to be coming in. And it's the right side of the bit, right? The right side of the bit is going to be coming down to that 0.5625 depth right here, this shelf. And then from there, it needs to move in to this line. Now, the total distance from the edge right here, the total distance from the edge here to here is 0.6854, but the distance from where the right side of my bit is cutting here to where the right side of the bit needs to be moved into here, that distance is 0.3304. So that's how far over I need to shift in and then back out. Okay. So now, technically, I would not need to do that shift at all, if my, and I mean, even in a sheet form, I might not have to do that shift, but if these were individual parts to where my 1.25 inch, and bear with me a second. That magnet. Get my diameter correct again. My large diameter is 1 3/16. 1 3/16. I have that measurement actually over here. 1.1875, 1.188, they rounded up. But anyway, 1 3/16. So let me draw that circle just so you can understand what I'm about to tell you. 1.1875. Okay. If these were individual pieces, individual strips that I had, two-sided tape or clamped down, whatever, I don't care. As long as they're held to the table, this bit, all it would need to do is it would need to come in, and I would have the line where it actually needs to go, this 0.6845 line. But the right side of it would need to just drop down to the depth of 0.5625, come across, clear that piece of wood, and then raise up, right? So down, over, up, and it would just cut that slot right across. Okay. Now, this is a big bit, and I have a board right here. I have a board, and I have these things spaced apart, a certain distance and everything. So when the center of my bit, is here and all, it is, as the diameter and everything is almost, it's wider than my piece. So what we're doing is we're actually stepping out here on the 0.354 line. We've got the bit just dropping down in that area. Now, all this has been cleared. This hasn't. So it's going to be kind of milling a little, it's going to take passes. It's not going to do it in one pass unless I did a pocket cut and I removed all this material or something with an end mill. But this is an end mill too. If this isn't us, you can't plunge with this bit. So ignore everything I just said. So I would have to clear out this area with an end mill first, because I can't plunge with this bit because the cutters are on the end of the bit. There's nothing in the middle, so it can't plunge. But this bit is going to come down to 0.5625. It's going to move over 0.3304. It's going to move back 0.3304, and it's going to raise up. So that's the tool path that it's going to make. And so in the imagine, if you will, let me first clear out a pocket here. So let's say that Now, again, if this was individual pieces, I wouldn't have to do this. Let me get on the line there. 1/4 inch end mill is fine. 0.5625. Oh, 1/4 inch end mill, select. I don't know why I'm doing a profile, you goofball. Pocket cut. Now that's going to remove all this material and everything, but my bit is going to be traveling. So this is the G code, right? So my bit is starting at X0, Y0 down here in the corner of the board. So the center of the bit is starting there. I don't know why it's not letting me snap. It needs to start there, right? So that's my 0, 0. It needs to travel over to this location to where the right side of the bit is here and centered on that line. I can turn that off, uncheck that. So it needs to travel to this location, which is 8.5 inches up on Y, 0.5938 inches on X. So my G code would look something like this. G17, G0, X 0.000, Y 0.000, S 16,000, M3. So that's going to, I need to also raise up to a safe height. That would help too. G0Z 0.80. Okay, so when I hit start, I'm going to raise up to a safe height. Then I'm going to make sure I'm at home, and the spindle is going to turn on to 16,000 RPMs. And then I'm going to rapid move G0 X 0.5983, Y 8.50, and then my first plunge is going to be G1, Z 0.5625. Now this is, again, I've already pocketed out all that area, so there's nothing underneath, right? So I can do it in one pass. So 0.5625, and it's going to be a plunge rate F. I'll go F15. Then I'm going to make from that position, I need to make an X move, okay, a linear move, and I'm already at 0.5983, and I need to move over an additional 0.3304, was it? Let me see here. Yeah, 0.3304. I need to move over an additional 0.3304. So I'm already here. So G1X, I actually have to use a calculator because I am not that good this late at night. Let's see here. 0.5983 plus 0.3304 equals 0.9287. 0.9287. So X 0.9287. And that's going to be a feed rate. We'll just call it 35. Now, it's staying at this Y position, and it's simply just moving from the X position right here, 0.5983. It's moving over from 0.5983 to 0.9287, that 3304. Now, it needs to come back. Doesn't want to raise up and like that. We're just cutting the slot, so it needs to come back. So the next pass is going to be a G1. I don't have to keep writing G1. It's already a G1. So I could just simply write X 0.5983. Okay. And then my next line is the Z is going to be at this point raising up back to my safe height. So it's going to be, again, this can be a rapid move because I've done the cut that I need to do. So it can be a G0, Z 0.800. And we can do an F, I don't know, whatever you want it to be. We'll just make it 15. And then it don't even need to put the F code at that point. But and then from there, it needs to return back to G0, X 0.00, Y 0.00. And then M5 spindle off, M30 into program, right? So this would be the G code to cut that slot, to tell that bit to go over, come down, come over, come back, come up, come back home. Now, if I was using a conversational program like Kipware and everything, it would ask me, my start point would be 0, 0. It would ask me where the location that my starting, point of the cut, the move and everything. In that case, it would be, the 0.5983 is what I would program into that box. My Z depth would be the 5625. I'd program that into that box. How long my slot is. Now would be the different in how long the slot is or the movement I need to make. It would only be 0.3304. So when it's already in that position, I just need to move that far and then come back and then raise up and then come back home, right? So I only have to fill in a few parameters and it'll do the rest. And it would spit out this little G code. And then that's what I run, right? So that's where conversational comes in. But that would be my G code for that particular toolpath on all the parts. I would just have to figure out the location for the center of each of these parts. And that would be my Y location. Because all these parts are lined up, if all of these were getting that same slot cut on the end here, which they're not, you got to think about how there's 6 pieces here. We only have 4 pieces in a frame, right? 2 of the pieces are, they're going to be opposite of each other. So we're going to have one, let's say 2, 3. So I could have these cuts on each end of this piece. I could have the other cuts on each end of the other piece, and I would need to do that 2 more times. And then that would be my lot mitered parts, right? So all I have to do is know for this particular slot cut, just this one, because that's the only one that movement has to happen. All the rest of them are just tool paths, just like we created the first time around, right? But it's just that one slot move that we'd have to write our own little design toolpath and all. Okay, let's bring JR up for just a second. JR, wake up. Here we go. I'm just kidding. Hey, buddy, what's happening? Am I making sense? And I want that answer in the chat too. But let's see here. Whiteboard. JR said to me, would have whiteboard 12 to do the 3 lot toolpaths. Have you cut this one yet? Okay, good question. So he was telling me how he would do it, like with a 12-inch board and stuff, but he asked a very important question after that. Have you fiddled with this one yet with tolerances and everything? On here, as far as the fit, right? On this piece here, when that bit is coming down and, cutting the line and everything, if I was going to open this slot up a little bit more, which would basically be on this side, I wouldn't open it up on this side. But if I was going to open this up or make this a little bit thinner so it fits in here, easier kind of deal, then I could create that little bit of an offset movement from my profile line where the bit's going to come down and cut. But I have never needed to do that and everything. Usually the cut is the fit's pretty sweet. And if anything, there would be just a little bit of the only part that would need any touch up, and then maybe a little bit of light sanding on here to get it to fit into that groove. But if I wanted to do it in the form of kind of reducing it a little bit so that it would, slide in a little easier, then that when that 1/4 inch bit comes down to make this slot right here, I would have it come down and make this slot, but then there would be another line just a few, like 2/1000ths of an inch or whatever to the right of it that would have a profile toolpath as well. So it would come down and cut, and then it would shift over and cut a little bit more, just shaving a little bit off this edge right here. That would be it. That would be the only that'd be the only adjustment that I would really need to make on that, JR. I don't know if that answers your question, but
well, it does. I'm just also wondering about, when we put glue on there, is it going to swell too much to get the thing in?
Oh God, no. The end grain, that glue is going to suck up into that end grain and everything, and then it's going to squeeze out. It's just like if I take two identical pieces over to the table saw and I cut, or the router table and all, I'm cutting the same, slot. There's no tolerance adjustments or anything, there, or anything like that for glue space or anything like that. That's not going to be a concern for me. Now, if I wanted to, let me take this and here, if glue space 1, like I said, if I open up that slot a little bit, it's bringing it down a little, but I could also take this and just a few thousandths of an inch, back this line off here, which is that top. I could skim the top of that off, reducing that. I don't want to bring my slot in any further. I don't want, because my bit, slot, I don't want to take a chance of cutting this edge right here. But if I needed to create a little glue gap right there, then this part, I would be shaving a few thousandths of an inch off of this. So I'd have a profile coming down, just taking, 0.002 or something, shaving off that. But I've never really had to deal with all that. I just run the tool pass, and everything on that with the cutter. So I've never really had to adjust for anything. I'm trying to think back if I ever had to sand or anything like that, to get it to fit. Oh no, I don't think I even had to sand it. But again, I would just, on that profile line that's coming down this line here, there would be another line not on this piece, not on this one, on this piece. There'd be another line just a few thousandths of an inch over, and that profile cut would be cutting to the same depth, but it would just be shifting over slightly, reducing the size of that. So that lowers that so it fits into here better. And again, I would be shaving off the end of that a little bit if I wanted, to create a glue space in there. So a minor little, still, it would be a profile cut on the line. I think, let me see how wide that piece is. Measure. Yeah, 1/4 inch. So my bit would just be coming down, right on, you have a center line right here. My bit would just be coming down and just milling off a few, a little bit of that across, it would come down and take off just a few thousandths of that little top. And that, by doing that, that would give me a glue space in here to where, now keep this in mind, but though, you're seeing this joint from the side of your frame, lock miter joint. So you don't want that gap too big. Let me see here. Dun, dun, dun. Give me just a second. When we're looking at that frame and that lock miter joint, we're seeing it from the edge, right? You know, as far as the aesthetics and everything. So let me see. Here's another one. Open image in a new tab. I don't know how well that shows that. Oh, hold on a second. We're all big and small. Hold on a second, JR. I got to pop back up here. You know, here's kind of a close up of that, but then, you know, this, we're seeing it from the edge. So if I'm going to, you know, if I'm going to have a gap there, of course, when I'm sanding these two edges right here, that sawdust and glue will fill in, you know, kind of fill in that void, right? You know, to give me that near perfect, you know, joint look. But I shouldn't have to take too much. Now, when these, bear with me just a second. Come on now. What's going on my screen? When these, you know, when these two parts, you know, slot together and everything, I shouldn't have to take too much. Now, this is a different profile lock miter that you can see that shoulder's much wider than the one that we're, you know, the one that I designed. But when those two pieces glue together, I want a nice tight joint and everything. So, yeah. But, ooh. I don't know what's going on my screen, but in order to create, come on now, what's happening? My screen's shutting on and off. Are y'all seeing that? Is it blacking out on your side?
Yeah.
Okay.
Is that coming from your laptop or?
No, it's coming from my desktop. I think one of my cables is not plugged in fully, but let me turn these dimensions off real quick. On the parts like this, and this isn't the only part you can do this with, you know, there's all kinds of you can come up with all kinds of reasons to use profile based tool paths to create all kinds of things. So one of them, I'll give you an example of one of them where I use profile based toolpath. What is going on with my screen?
Where's Tiger Lily?
That is I don't know where Tiger Lily is. Hold on a second. Let me see what's I don't know. I have to check my wiring. I don't know what the deal is. But I'm hoping my screen is not burning out. That's not a cheap screen. Okay. What was I going to say? Oh, I'll show you an example of where I use profile-based tool pathing. And let's go to let me plug in a flash drive. Open an existing file. turkey. Let me turn off these toolpaths and let me turn off dimensions. Okay. On this particular turkey pot here, the outside wall has an 8-degree undercut. So the part from the base of the part up to the top of the rim, sorry, did we, from the base of the part up to the top of the rim, there's an 8-degree angle. And so in this instance, I have an 8-degree dovetail bit that comes in. By the time it gets down, to a certain depth, it comes in, it comes over, and that profile bit literally follows the profile circle all the way around and cuts that 8-degree inner, undercut, if you will. It cuts that 8-degree undercut all the way around this part. After it makes the full revolution, it moves out so that, the bit, like if it didn't move out and it went straight up, it would just rip that part right, cut right through it, right? So after it makes that full revolution, it backs up to a safe distance and then it raises up off the material. So its only purpose, that conversational, is when I snap this part into the jig, the dovetail bit moves over, comes down, goes around, backs up, comes up. So it comes down, it moves in, goes around, backs up, comes up, and then it comes back home. That's all it does. That's the one tool path, and so that's just like that T slot for that miter cut. It's going to come down, in, come back out, and then you're done, type of thing. So there's I'm sure there's reasons that you would want to come in and you could use special profiles and all. For me, when I'm actually doing spindles and things like that, I make sure I have the router bit, and I'm running a profile cut. So when my 4th axis is 2440, so my router is actually pivoted 90 degrees and the spindle's over here. So what's happening is my bit comes in to whatever, however many passes I'm taking, but it comes into a depth, and then my spindle turns 360 degrees, and then the bit steps in, it turns 360 degrees, bit steps in, turns 360 degrees, and it keeps doing that until it gets to its whatever the full depth of the cut is. In this case, it would be 0.6562 inches, and where I'm getting that number is from the very tip of the bit to the top of the bit vertically to the top of this roundover, that 0.6562. So when this bit comes in and makes its pass, it's going to come in and pass. Let me zoom in here, zoom. It's going to make its pass. It's going to rotate. It's going to step in a little bit more on the Z, rotate, step in a little bit more on the Z, rotate, step a little bit. And then by the time it gets there, it does its final pass. And then that bit moves all the way out. It moves all the way out, the Z backs off, and then that part has been cut. So that's all done. It's a matter of, and it does it in minutes, and in most cases, depending on what feed rate I have my Y spinning at and everything, it's only just a few minutes for that bit to make that cut. And by the time it's done, it's cut the shape of that profile. And I have a variety of these profile bits and stuff, but you can't buy them all. I mean, that's an expensive set of bits right there. But, you know, when you have it, you could go to here. Let me show you. So let me make myself big. Let me bear with me a second.
Any burning on when you're doing that, Laney?
No, no, sir. No, because you're still making passes. Bear with me. Let me.
Because I just think you're doing a 360, and then you're stopping, and then your spindle's coming in with your router bit still spinning when it's basically still sitting in one place.
Sure.
But no, you've never seen any burning.
No, it removes that material. Now you're thinking that you know, when the bit comes in, right, and that makes that turn, that next pass step, right? It's not backing up, and then, you know, here there's two separate moves there, Jared. Remember, this isn't a lathe, you know, going, you know, 360 miles an hour, right? This thing only turns and it stops, right? So just like with any pass step, even if I was cutting on the table, my bit is, you know, coming into a certain depth, it's making its rotation. And when it stops, my bit is stepping down to its next pass, right? So it's cleared that area. Now it starts rotating again. Step, rotate again. So no, there's no burning.
Yep.
You know,
all right. Now I see it.
Yeah. I can see what you're saying. I don't know if you were thinking, you might not have been. I'm just assuming. Assumption is the mother of all fuck ups. But that this part is just spinning and this bit is just plunging into the spinning part, right? You know, kind of thing. And it's not, you know, it's moving 360 and it stops, step down to my next pass, rotate, next pass, rotate, next pass, rotate, right? So, and depending on, you know, what profile I'm using, you know, or a combination of profiles. And let me show you what I mean by combination of profiles, which is pretty cool. Let's say that I'll grab two separate profiles. So let's grab this one. I'm going to hold down my control key and drag it over here for a minute. I'm just going to drag it in the middle of my room until I grab the other one. Let's grab this one. Hold down the control key. Get down there. And then let's go with a cove. So we'll do a 1.5 inch diameter cove. So, okay. Now, using a combination of random bits. Now, this is just 3 random bits I grabbed. There's, you know, no rhyme or reason here. But let's say that this bit is only cutting down this deep.
You're large, lady.
Okay. Oh, I'm large. I mean, it's in my head. Hold on a second. Okay. So I'm using 3 profiles here. So let me grab them 3 again. Let me move that there. Okay. So I've got this profile, and this profile. So 3 separate router bits here. And on this, let's say that on this bit, it's only going to come in to this depth here, and it's going to just cut that part. Basically, it's going to be kind of that. And then from there, we have this bit that is going to step there. And then from here, this bit will step here. Now, the lines of the toolpaths for these bits, of course, were based off the center of the bit, right? So we'd have a line here. We'd have a line here. And a line there. And then also, let's drag this to here. Here. And here. Now, those lines don't mean anything. The center of the bit is, that's what the bit's running. Now, what I want to do is I want to take and draw a center line. And I want to take these three profiles just as they are. Hold down the shift key, select that center line. I want to flip them about that line. And I'm going to come in and use my scissors. This trim, 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 trim. Cut that away. Cut that away. This one's grouped. It won't cut right now. I'll have to go back and ungroup it. Cut that away and that away. Okay, bear with me just a second. This one's grouped together. Ungroup. Trim, trim. Hold on, ungroup these, ungroup. Let's see, that one is plunging in more than that, so that piece of wood would be gone there. That's gone, that's gone, that's gone. Okay, now, bear with me. One more, trim away that, that. Oh. Oh, Laney. I don't need the scissors for that. All right. So this profile, and the reason why I have these vertical lines here is just to kind of show, you know, resemble like a three-dimensional view. There would be one more line to really make it look like it's supposed to look, would be one more line right there. Okay. So creating this profile, in order to do that, oops. Creating this profile, my one bit cut down a certain depth. My second bit cut down a certain depth, and my third bit cut down a certain depth, but they all followed this one pass. So when they just moved over to that location where that line is, and then my part, they went down to their depth, and then my part rotated 360 degrees. And moved over to the other line, come down, rotate 360 degrees. Move over, and of course I would be changing bits. It would not be one bit moving over, but I would change bits, you know, from one bit to the other to create this unique profile right here, cutting this in a matter of minutes for that part just to rotate a full rotation versus if I did it as a 3D model where my ball nose bit would have to go and then step over 8%, 8%, 8%, you know, that kind of thing. So using a combination of router bits, and let me bear with me just a second here. Let me get rid of that. But I'll get rid of these other lines. Now it doesn't look like a spindle, but that unique shape, and again, I just made up a shape, you know, based on 3 router bits, but depending on how far that bit plunges or how far the step over of this bit is and the far step over this bit, you know, wherever they are, whatever they get to, you know, I can create a combination of a wide variety of different profiles and things like that. It doesn't have to be just one bit for one profile. I could use multiple bits and stack them to create, you know, whatever I wanted to be, and things. So we can, you know, using router bits, if I did this cut in a 3D cut with an 1/8 inch tapered ball nose, it would take me hours just to get that, you know, 8% step over, 8% step over, 8% step over, 8% step over, you know, for that, you know, bit to cut. If I was only cutting here, you know, that would take so long versus my bit just coming down and doing one rotation, one rotation, one rotation, you know, kind of deal. And it's a rotation at whatever, you know, 55 inches a minute, 100 inches a minute, whatever it is, whatever you want it to be. And I'll show my competition. Hold on a second. My competition. Let's see here. I'll show an example. Okay, so we're going to watch a little bit of a quick little 20-second video. And let's get to it. All right. When it comes to, I'll maximize this up to the screen and everything. So this spindle, let me get back up a little bit here. This spindle, they're using profile-based router bits and single line, you know, pass, you know, locations like, you know, go from here to here. In this case, they're using conversation on the spiral here. They're using conversational cam. Basically, the bit goes down to a certain depth, and as that bit travels along the x-axis, when the bit gets from, let's say I'm making a 5-inch move. When that bit makes a 5-inch move in conversational cam, I can say I want the spindle to have made a 75-degree turn. So while that bit comes in here, that bit starts moving and that spindle starts turning at the same time. And by the time that bit reaches 5 inches, this has made a 75-degree turn, you know, or let's say 270-degree turn, you know, 3/4, you know, turn to create like a spiral. So this is what you're going to see in this little 20-second clip here. So let's take a look at what like a conversational cam toolpath might look like. So that bit is coming down as that part is turning. So that bit has the, you know, the profile. Let me see here. They're talking about the headache of the CAD CAM design. So what you're seeing is in CAD CAM, creating that modeled part and everything, doing this step over, you're looking at a runtime of 7 hours and 46 minutes. Right? 7 hours and 46-minute runtime based on, you know, a Vectric 3D toolpath. Now, a conversational package and everything, you go in and answer parameter questions, you know, where you want it to start, where you want it to finish. You just go in and fill in the blanks, and it writes the G code for that. And so now this bit is coming down. It's making a 90-degree turn. They got it fast forwarding and all. But it's making these turns and all using these special profile bits, going from point A to point B as that spindle is making a 360-degree turn, and it's using those profile bits just to create the cuts, and it's a 39-minute cut when you're using conversational carving. So if I have the point of this little video is if I have 100 of these spindles, I've got production, I've got 100 of them that I got to make. If I have to make 100 of these at 7 hours a piece, then my profits are out the door, right? But using router bit specific profiles and things, what they're kind of drawing here, and everything, using router bit specific profiles to where that bit comes down and makes a certain pass. So as it travels from point A to B, the bit needs to make a 360-degree turn, but it's stepping down. So it's taking that 360-degree turn, stepping to the next step, all the way, all those passes. It's nonstop. That's what we were talking about just a minute ago, JR. It's nonstop. So, it comes around and that just comes down and it starts removing that material. So you're just plunging right straight down as that's turning, constantly turning. The bit's just dropping down to where it's got to drop to. So making that unique spindle and those unique profiles, using those profiled radius bits or whatever they might be, we can create that very unique profile on that spindle in a very short period of time. Here, it's pocketing out this area, and then it's going to tell it to turn 90 degrees. So once this pocket is complete, then it's going to turn 90 degrees, and it's going to do the next pocket, right? And then the spindle is going to turn, do this slot. It's going to raise up, do the other slot. Then again, it's going to turn back 90 degrees and do that slot, right? 90 degrees, make that cut, 90 degrees, make that cut, 90 degrees, make that cut, that kind of thing. So we're not going to watch this whole video, but that's the power of conversational CAM or router bit profile carving versus, CAD CAM, rat type carving and everything. And so that's what I'm trying to expose you all to a little bit. All right, let's go back to JR here.
Well, that also answers another question that I was going to have for you later on, but
yeah.
Cool.
Yeah, what was the question?
I'm making a figure, and the body of the figure is a trapezoid.
Okay.
Okay. On the sides of the trapezoids, I have to drill 3/4 inch holes in 3/4 of an inch.
Mm-hmm.
But it's also being on the trapezoid, so it's not like I can actually move the spindle to come in on the angle to hit that. But I could be able to put that on the rotary table, index it so that it's, north, south, and then cut in. Right.
And then it will, depending on, the size of the trapezoid, let's say, from here, you need it to turn 35 degrees and do your next drill pattern or whatever it is. And then another 35 degrees to the other side of the trapezoid, that kind of thing. And that's all you're doing. You're having that spindle turn a certain degree versus, or it could be inches. You could have it turn, if you knew the math, rotate 1.6 inches and then come down, but it's easier with degrees, right? I need to turn 45 degrees and then I need to make that drill another 45 on that side and everything. And so it's much more efficient, let's say that. So and when time, if it's a hobby type thing and you can spend 7 hours on a table leg, no problem, right? Lay it out and do the 3D carving and all that. But if it's something in production where time is money, then we need to be able to create toolpaths in a way that and CAD CAM design doesn't do that. CAD CAM doesn't do that. The whole purpose of CAD CAM is CAD, the design. You draw out the design, you create the toolpaths and all, or the 2D or 3D carvings and everything. But in this case, what we're doing is we're a little bit of conversational CAM in here, in a sense that we are drawing just simple line paths that the bit has to follow or the part has to turn to or whatever. We have that simple line path, and then it's our bit that does the work. When the bit comes down to a certain depth and that follows that path, then it cuts that shape, that design. I don't have to go into any modeling or anything to get that done. So
that's exactly what I'm looking to do. Cause
yeah,
with the machine,
right.
I've got that.
The with the Kipware
outlined in our previous video,
software, bear with me just a second here. Bear with me just a moment. Let me see if it. Come on. Let me get the tab to come over. This Kipware conversational. Where was it? Where was it? This one. Maximize this back up. So, you know, I might have on, let me back up a little bit. So I might have a variety of operations that I need to do. Now, this is the turning one. There's one for milling too, pockets and stuff like that. But let me back up. Wrong. Pause. So in this one, I might have to remove material from an area out of pocket. So I literally look at the graphic of what it is I'm trying to do, and I click on that operation, and it opens up a dialog box, right? And so this would be the first operation with the first router bit. And what I need to do is come in and tell it what tool that I'm going to be using. And then let me see here. Set the, too far. Set the type of operation. So all these have names. So let's say, for instance, that this one that I'm pointing at is the piston facing. And then the one next to it is piston turning, and then the turning radius. So I choose the one, I set the tool and whatever the offset is, the distance and everything. And then I add that to my cycle. And then I choose the next one and add that to my cycle and choose the next one. And then I assign the tools to it. And when I'm done, I click on the button to create the G code, and it simply writes the G code on those, combining those, three operations. And then if you have an automatic tool changer, it would go do the tool change as well. If not, it's a manual tool change. But it's a very just straightforward type of, you just fill in the blanks. Now, that's on a turning. If we were looking at let me see here, a milling example. Are they going to have a milling example? Turn.
Are they two separate packages, Laney? One for milling, one for lathe?
Two separate operations. So yeah, one for milling, one for lathe, but they're bundled into one. So you have a tab for milling and a tab for turning. So let me see here. All right, this would be a good example. Maximize this up. So here I might be doing a surfacing. I might be doing a chamfer or a flute, like a tapered flute. I might be milling material off the two ends, and I'm in small screen. Let me go back big again. Lord of mercy. And let me hold on a minute, ladies and gentlemen. We're getting somewhere. So let me pop this off. So I might be just milling like a surface cut, like a surface toolpath, right? So I come over to the surface icon where, it shows the, surface being milled. This is a fluting, a tapered flute. This is a cylinder surface type of thing. This is pocketing off two ends. So, this is doing a groove cut, like a pocket cut. So each one of these operations, and also I click on that operation, and it opens up this parameter here. And then I need to, bottom left corner of my material is going to be 0, 0. And then I go in and fill in the blanks. So by the time it's all said and done, let's say I'm going, I need it to travel to -2 inches, -2 inches on X and Y, down 0.1 inch on Z, the length of the stock, the width of the stock, the thickness of the stock, how much I'm removing. So all I'm doing is I'm filling in the blanks. and everything. And when it's all said and done, once that's all done, then I come in and I add that tool or type of material, and the type of material, this particular software automatically sets your feeds and speeds based on the material, based on what you have in your tool database and everything. So it sets all those parameters and everything, and then you create program, and it writes the G code. So, by the time it's, you have that face top, and you come in and you can preview the G code before you run it, but it simply just writes it, right? And it's just like calculating a toolpath, but we just had to answer a couple of little questions and plug in some numbers. We didn't have to go in and actually create the design and do this, do that, or anything like that. So what we're doing in Vectric is, in a sense, we're kind of emulating that a little bit, where we're drawing a path. We're drawing a path, and then we're on that path, we're creating a profile with a certain depth and a certain bit, and the bit's going to go to that depth and follow that path, right? And then, it creates that cut, whatever it is. But it's the profile of the bit that's creating that. So the V bit is creating our chamfer. The end mill is creating our flats. The T slot bit is creating that undercut slot. When it comes to the rotary spindle, our rope bit is creating this nice decorative groove. Our rosary bit, whatever it is, I don't know the names of all the bits and everything, is creating, this groove and all. So we're literally using that bit to create that cut. And if it's something that you've never really looked into or never really thought about or considered, incorporating profile-based cuts. When I say profile, I'm talking about not a profile toolpath. I'm talking about the profile of your router bit. Profile-based cuts to where this particular bit is following a certain path and everything at a certain depth. Definitely, look in, check it out, because it's definitely a time saver. If I do, I'm going to be starting a relationship with Kipware to where hopefully in the future we'll be offering that software to digital woodcarver customers and stuff. But if that happens and everything, I'll definitely be able to show you more of that Kipware software and its capabilities and all, and where there's a place for conventional conversational carving versus CAD/CAM carving. There's a place for it. And generally that place is in a production environment at the shop floor. When the operator's standing at the machine, he needs that machine to turn a certain way, pick up a certain bit, to make a certain cut. He just needs to be able to fill in the blanks. He does not have time, he or she does not have time to sit down at a computer, create a design, create the tool paths for the design, calculate the tool paths, and all that stuff. That's for the CAD/CAM specialist in the other office to do when they have those specialty type programs. That's for them to do, and then they send the tool paths out to the operator at the machine. When the operator's at the machine and he needs to make certain cuts, he needs to be able to answer a few parameters, fill in a few parameters, and make that G code and go. So that's where conversational comes into play. So,
or I can sit there and do up 16, 17 designs, turn it over to my operators, and go continue on designing and setting the conversational stuff up.
Yes. Yeah. And on the example, I don't know if I think it was the Kipware guy I was explaining, but like legacy, on that table leg that you saw, if there would have been any part of that table leg that had a 3D model, let's say of an alligator or a grapevine or something, they would have drawn two vectors to create boundaries, and they would have done a 3D rough and a 3D finish in Vectric. They use Vectric too. They would have been a 3D rough and 3D finish cut on that grapevine design on that just that section of the leg. But the rest of that leg, they're doing the conversational carving where they have a path and they have a router bit that's cutting that path. And it's the combination, because again, there's a place and a time for both, but that combination that takes a 7-hour carving down to a 30-minute carving kind of thing, or whatever it might be, so it's crazy. It's insane. So Dragon Claw, right? the Queen Anne leg, you know, that ball and claw. Is that what you're referring to, Brooks? But well, ladies and gentlemen, I mean, that's really kind of the conversation. It's just kind of an introductory to vector, simplifying our vectors and knowing our parameters to use a particular bit to send a bit to a certain area, a certain depth, to make a certain profile, to make a certain cut, right? And using a combination of bits, a variety of bits to run all of those combinations and things to accomplish whatever the job is. And in my case of this flat board, 2 of my parts are going to be on each end are going to be cutting this profile, or, you know, running these tool paths to cut those on each end. And I would create the vectors for each one. And then on 2 of my other boards, you know, are going to be the tool paths to run this. Now, this one is just an end mill and a V bit, no T-slot bit. The end mill comes down to a certain depth where this green dot is here and clears out that waste. And then my V bit starts down here and cuts the rest of the way, that 1/4 of an inch. And it creates that chamfer. And my end mill then, you know, raises up, comes over, and comes down to a certain depth to cut out to remove this slot. And again, if that slot is wider than 1/4 of an inch, then the end mill is running a couple of paths, right? A couple of lines to widen that gap, right? And then my V bit is coming down again, you know, that 1/16 of an inch to, you know, cut that little chamfer. You know, it's just coming down, cutting across, and done. So I would be setting these up, and then that would be much faster than me trying to create a 3D model of this or what have you, you know. And really, with a 3D model, I really couldn't do that undercut slot. Vectric can't even create that undercut slot. So let me just, this will be the last thing. I'm going to show you how to alter the Vectric toolpath. So on this one, this bit, I wrote the G code. Remember, I wrote the little snippet of G code to tell that bit what to do. But let's say that I created the toolpath in Vectric. So in Vectric, I'm going to basically come in and I'm going to have a point out here where the bit is not going to travel across. It's just going to move to this location, and it's going to plunge down and back up, right? So it would be like a drilling toolpath, if you will, and everything. But in this case, let's create in the center of this bit. I'm going to create a point. I actually don't need to create anything. I can just use this circle. I'm a dumbass. Sorry. I'm going to come over here to a drilling toolpath. This is going to cut 0.5625 inches deep. I'm going to be using my 1.25" diameter T-slot bit, which is, I'll have to add that tool. So let's come in here, and it's going to be a 1.25 diameter bit, 2 flute. It's going to take 1/8 of an inch per pass, let's say, but I'll have all that area cleared out, so I'm not worried about that. Step over 33.3% of the bit, spin at 16,000 RPMs. 50 and 20 is fine for this example. So that's the bit that I'm going to be using, and I want it to it's going to use pecking. If I was drilling it down, right, I want to use pecking. I don't want it plunging straight down. But in this case, that area has already been pocketed out. So I just need the bit to move over and come down and back up, right, for this particular operation. So no pecking, and I'm going to calculate the toolpath. I'm going to, so what will happen is, let's get to the top view here. If I were to preview that, the bit is going to come over and it's going to drop down, come up, and then it'll come back home, right? So that's what it's going to do. But I actually need it when it's down. I need it to make that move over and back. So let's save the toolpath. So we're going to go save toolpath. We'll save it we'll save it here. So this will be sample trash. I'm going to call it trash so I know to delete it. T slot. And I'm going to hit save. Now I'm going to go in and I'm going to edit that with Notepad is fine, or I could edit it with, I'm using Notepad++. Hold on a second. No. Hold on a minute. File, open. It's there. Don't tell me it doesn't exist. Let's go to Lexar, Charlie's Turkey Pot, sample trash. There we go. All right. So can y'all see my head's in the way? Hold on. Let me move over to the right. Okay. This is that G code right here. Okay. That's it. So the router, when I hit start, the router raises up to a safe height. It makes sure it's at home. It ramps up. It turns on the router or spindle. And if it's a spindle, it ramps up to 16,000 RPMs. It moves over to the first location and then it plunges down to that. And I'm starting at the bottom of my material. So that's the bottom left corner. And I'm zeroing out on the table surface for this job. So that's why the number looks like it's 0.1875 instead of 0.5625. All right. But when I get down to this location, from there, in this toolpath that was created by Vectric, it simply raises back up to the safe height and back home, right? So what I need to do is when it's down in this location, I need it to G1X, and I need it to shift over that 0.3304, but I need it to be that 0.5938 plus, because that's where I got to go, 0.5938. That's where I'm at now, but I need to move over another 0.3304 inches. So I need to be G1X 0.9, and I got to remember what my number was. It was 0.9287, 0.9287, which is 0.5938 plus 0.3304, where I got to move to. It's got to go there. Okay. So it's going to move into that position. Then from there, I need it to come back. G1, I don't necessarily have to keep writing the G1, but that's fine. G1X 0.5938. Then when it gets back here, then I need it to raise up, which is already there, go back to a safe height and go back home. So I had to add in these two X movements to that drilling toolpath. I had to move. It's going to go over. It's going to come down to that depth. But now my X movement has to come over and then back up, right? So I had to add in that over and back line, right? So now I've altered, I saved that toolpath, and now I've just altered that toolpath to create that T slot, right? That's what we do. That's what we do. All right, coming back. Let's see here. It's like a keyhole toolpath, right? It's like a keyhole toolpath. If it was a keyhole toolpath, if I was using the keyhole slot in Vectric for that, who said that? Who said keyhole? Brooks Martin. If I was doing a keyhole toolpath in that instance, okay, it would be horizontal from left to right. So from my plunge, I need to move left to right and then back out the same hole, right? You know, so it would be a left to right. The depth of my slot would be that 0.5625. The length of my slot would be that 0.3304. Okay. The entry hole diameter would be that 1.25. And my slot diameter would be 1.25 because it's the same as the neck, you know, or that's the same. That's the, you know, whatever. But so I could calculate that tool path and based on, I don't know if I had that vector. Let me see if I had that vector selected. Hold on now, stop. I did have the vector selected, so hold on a second. Let's create it again. Gadgets, keyhole toolpath, horizontal left to right, 0.5625, 0.3304, 1.25, 1.25. Select the tool. I'll just select a dummy tool for right now. Let me make sure that's change saved. It did. Okay, good. Select and then click OK. The slot diameter must be less than the entry hole. Oh, sorry. Slot diameter really doesn't matter. So we'll just go 1 inch. Okay, click OK. All right, now on that keyhole toolpath, if I were to save that keyhole toolpath, we'll just call it keyhole toolpath. That's fine. And if I were to go back and open that, why does it do that? That's weird. Open says it doesn't exist when it actually does. So if we look here, so it raises up to a safe height. It makes sure it's at home. It turns on the router. In this case, I didn't change it. It's 24,000 RPMs. It moves over to that XY location, same as the other toolpath. It plunges down to the safe height and then down to the final cut. Now, this final cut says 0.1875. Remember, I'm zeroing out on the wasteboard, so that is 0.5625 inches deep. And then it steps over. Okay, it steps over in that X distance, and then it comes back. And then it raises up and then comes back home. So the same thing. Now, the only difference is on the step over. It is, if I'm 5938, yeah, 5938 plus, let me see the math, if the math 0.9241 minus 0.5938 equals, what the hell did I just hit? Oh, forgot to hit a decimal. Hold on. Decimal 9241 41 minus 0.5938, 0.3303 instead of 0.3304. So I don't think that 3 10,007 inches are gonna affect me none. So that's all the difference was. But so the keyhole toolpath did the same thing, Brooks. So the keyhole toolpath did but you know, those two lines that we added in manually, doing the drilling toolpath and adding those two lines manually, the keyhole toolpath created it automatically, right? So probably a better way to go, create the keyhole toolpath. So there you go. Very cool stuff. Very cool stuff. All right, ladies and gentlemen, let's get back to here. And here we're going to say our goodbyes, but hopefully, I don't know if y'all got anything out of tonight's class or if it was useful information or if it's something that you could see, you could, you know, to make you start kind of the wheels turning and stuff and kind of thinking. I wish I had one of my turkey pots and stuff, but basically, let's say that this was one of those turkey pots. The pot gets completely cut the part out of a big block of wood. The multiple parts get cut out and everything, you know, pocketed and profile cut and all that stuff. And then it gets drilled and everything. So the part, when it completely, the final profile cut, the part gets cut out, right? And then that part snaps in to a jig that I have mounted on the table. And on that jig on the table, my dovetail bit gets zeroed out on that XY0 of that jig, the coordinate and everything, and on the top of the material. And that dovetail bit travels over, it comes down, and it does a perimeter cut around that part, backs off, you know, so it comes down, comes in like the keyhole slot, but this time instead of coming in and back out, it actually comes in and comes around, then backs out, raises up, and comes back home, right? And so I have a jig with 5 of these parts in there, so they're all snapped in. So my dovetail bit comes in, drops down, in, around, out, up, moves over, down, in, around, out, up, over, down, in, around, back, up, you know, that kind of thing. And it's a very simple thing. And for those of you that aren't familiar with coordinate systems or offsets, not the Vectric offset that you see here, use offset, but actual CNC G-code offsets, G54 through G56. I'm going to show you Planet CNC TNG, our motion controller software. So I'll open up just the 2440 mil mode version of it. On my table, I have now my CNC, my 4848 CNC is sectioned off into 4 sections. A section where I just do miscellaneous carvings, a section that I have a jig where I make certain parts. Another section of the table has another jig for other parts, and they stay permanently mounted on the table unless I move them or change them out or something. But the XY0 position for each of those jigs, the home position for each of those jigs, that's a offset. And so if you look at my active G codes in this Planet CNC software, let me move my head one more last time. We'll say goodbye. And now I'm taking you kind of just down a little road trip here for a second.
That's okay. It's good stuff.
Yeah. In my active G code here, G54. So think about this. G54 is offset number 1. Okay, that's one place I could have on my table. G55 is offset number 2. It's another place I could have on my table. G56 is number 3. G57 is number 4. G58 is number 5, and G59 is number 6. So I can have 6 offsets set up in different coordinates on my table, different locations. So when I hit a button, that offset is now the XY0 kind of thing, you know, location. So now technically in Planet CNC, those offsets, they're called coordinate systems. And G54 is number one, that main system, right? Now I can actually have multiple coordinate systems, offsets in Planet CNC. And what it does when it gets to, and when it comes to the G code, when it gets to G59, which is, that number 6, then it starts going G59.1, G59.2, G59.3, and each of those could be offsets, right? And stuff. And so I could have multiples. Now, here's what happens. Let's say that on my CNC table, let's pretend this orange grid is my CNC right here. Okay. And I jog my machine over to the bottom left corner of jig number 1, right? Now I'm in G54 right now. Now to switch from G54 to the next coordinate system or to another offset, there's 2 ways I can do it in Planet CNC. Number 1, I can go to the MDI box and simply type in G55 and hit enter. And you'll see that now the software is operating in coordinate system number 2. I'm no longer in coordinate system number 2. And all. If I could also go to the machine menu, coordinate systems, you can see I'm in number 2, but I could also come in to coordinate systems and I could hit select and I could choose if I have, I got them named dust shoe jig, main table, turkey pot jig, that kind of thing. Not in this profile. This is a sample one, but so if I select main table, you can see that it switched me back to G54. If I came in and I went to coordinate system number 4, that's G57, right? So those coordinate systems. So let's go back to G54. I'll just do it in the MDI. G54. Now I'm over here at 7.0584 inches and all. Now I'm going to set that as 0, 0. Now what you're going to see is I have this red line here. And from my machine's home position, which is this red and green datum down here, to the location up there, you might not be able to see the red line. It's hard in the software, but there is a red line. It's a red dotted line right here. But that location is 0, 0 for now for this coordinate, right? And so in my G54, this location, if I go look at my coordinate system and I edit my coordinate system, I could have also set the coordinate system here as well too. So coordinate system 1, I currently have, set at 0.5 and 0.5 right off my limit switches and all. But I could come in and I could program in and say that this was, 7.0563. I could do it manually, or I could simply just come in and zero out there, right? Now, once I do that, okay, I'm at this location. All right, I'm at that location. So 7.0584, 7.0584. Now, if I switch over to coordinate system G55, which is coordinate system number 2 and everything, I am, and let me set this properly before I screw myself up. G54.
Make your screen large again, Laney.
Oh, dadgummit. Sorry. Hold on a second. Thanks, guys. Planet CNC seems to be the most inclusive software of G-code commands that I've ever looked into. Absolutely, 100%. I in my personal opinion, it beats out everybody. Planet CNC is phenomenal, and it's open. I can write any kind of script. I can do anything in it. It's phenomenal. So in my coordinate systems, let me go in and edit coordinate system. We'll set number 2. So coordinate system number 2, I'm going to set that at 7.0584 for For X, 7.0584 for Y. Now, I could also have Z set too, my offset. So from my table, if my jig was raised up, let's say my jig was 3/4 of an inch, and I was actually zeroing off on the jig, right? And that jig, when I stick my parts in there, let's say that my jig base, the top of my jig was my material or my machine bed, let's call it that. Then that offset distance from my table, my actual wasteboard to the top of that 3/4 inch jig, that would be my Z position, right? So 0.75. So now it knows that my 0 is actually 3/4 of an inch higher than it was in coordinate system number 1. But anyway, so let's say that I update this and everything, and I come in here, and coordinate system number 1 is, that half inch, and all. So I have these two coordinate systems. So I'm in coordinate system number 1. So right now, that half inch in, half inch up from my, when I do my homing procedure and stuff, that's kind of the 0 for coordinate system number 1, my main table. So let's now switch. Let me come over here and zero this out, right? I'll just zero that out. My coordinate system is still there, right? It still keeps track of that. But now I'm going to switch to, I'll just do it using this menu to make it easy for y'all. I'm going to select coordinate system number 2. Now what you're going to see, you see that datum switched over here. And if we look at the work position, I'm at, the work position is still offset. Let's clear the offset. There we go. So the 0, 0 for coordinate system number 2 is that 70584. Okay. So that's the machine now thinks it's, 0. And the reason why it says negative is because my router bit is way back here, right? If I tell my router bit to move to 0, it's going to move to the XY0 of that jig. And if I tell the router bit to move X 1 inch, Y 1 inch, that's 1 inch and 1 inch off of my 0 of that coordinate system. Now let's switch back to the other coordinate system. So here, coordinate system number 1, you can see my router bit is here. So I'm in, this location, right? If I tell my bit to go back to 0, it's going to travel back to 0 of coordinate system number 1, because that's the coordinate. I'm in G54. And so now I'm working off that location. So I can literally quadrant off sections of my CNC table if I had a big enough table. And I could literally, it's like I could have 6 mini tables in one, where this section of the table functions on one thing, this one functions on another, this one functions on another. And for me, coordinate system number 1, G54, that's just I can clamp anything in that area of the table, and I can carve something just quick and dirty. But if I'm running my dust shoes, if I'm running my turkey pots, if I'm running any of my other projects that are, production items, their jigs are mounted to the table, and I switch to the appropriate coordinate system, and I'm working off of that coordinate system for that jig. So once I home my machine, I can get right back perfectly to that XY0 of that jig just by moving to that coordinate system. I don't have to put a quick set block up and touch off X, Y, and Z. I had to do that initially when I set up the coordinate system. But once it's programmed in, it's programmed in. Once I home my machine, I can now tell it to go to this coordinate system XY0, and it's going to know exactly where to go. And now I'm working off that location of the table. So for me, that combined with conversational cam, where I can tell the bit to move this far, come down and cut, and then come back, and all these things, like having my dovetail bit move over, come down, come in, and come around, come back, and come home. That's not a a Vectric toolpath. That's a manual written toolpath or a conversational type toolpath where that one profile, 8-degree dovetail bit, it does its one job. That's all it does. And so, and on my case, my jig has 5 pieces, so it does its 5 jobs, right? And then when it's done, it comes back home. I pop in 5 new pieces, hit start, it does it again. Hit start, it does it again. It cuts, all it's doing is cutting that 8-degree undercut. So anyway, I hope it's late. We're going to end it here, but I hope that some of this information has been eye-opening. And everybody has, you all, if you're, I don't care if you're using Mach 3, Carbide Create, or whatever controller system, everybody has G-code offsets, and it's all the same. G54 through G59 is offset location 1, 2, 3, 4, 5, 6, right? Once you get to 6, depending on your controller, if you want 7, 8, 9, 10, it's G59.1, 0.2, 0.3, and that kind of thing. But everybody has that. Only few select use it. In my case, my table, I have one CNC machine, but it's a production machine, and I need to be able to put on different hats. I need to be making turkey calls. I need to be making dust hoods, whatever. So I need to be able to move over to whatever jig without spending a lot of time trying to find the XY0 of this jig or the XY0 of that jig to make sure that, God, if I'm off, it's not going to cut. It's going to screw up that whole part that's in there and that piece of material. I set up and create my coordinate system on my machine. And when I home my machine, I can move to that coordinate every single time and run that, as long as I don't forget to switch from coordinate system 1 to 2 to 3 to 4 to 5 kind of thing. So, and again, you in your controller, you have an MDI box, a MIDI box, where you can type in manual data input. I don't care if it's Mach 3, Planet CNC, or whatever. You could type in G55 and it switches you to that coordinate system, G56, G57, that kind of thing. And you're in, and right here, your active G codes on Mach 3, it's a list at the bottom. It shows you the list of all your active G codes, what's active at that time. And by default, if you looked, you would probably see the same thing, G54, G64, 90, 90.1. And that G54, that's the coordinate system. Now, if I change this to G57, it changes right here to G57. So and on Mach 3, it would change it right at the bottom. It would say G57. Now you're operating in that coordinate system with those offsets for that coordinate system, right? So look into that. It's a phenomenal way of turning a hobby machine into a small production machine. It's if you got room to set up little jigs to do little operations, you might be cutting out little medallions and little necklace charms. I don't care what you're doing, but you might have little stations, if you will, on your table. So what do you think, JR?
I think this is great. I can't wait to try out the lock miter. And I'm really excited, and I hope we can strike a deal with Ripsaw or those guys, because I can see that being really handy.
Brooks, I'll answer your question in just a second, but here's what my conversation with Kitware is I see, as a CNC manufacturer, I see I don't care what unit it is, whether it's our mini carver all the way up to our 5100 commercial unit. I see a big disconnect, a loss for our customers, if you will, of not being able to do conversational machining to help with small production runs if they have a small woodworking business. Now conversational software now, like with Kitware, they might have 38 operations that they do: surface, pocket cut, bevel cut, fluting cut, right? These operations. They might have just 38 of them. Legacy's Conversational Cam Pro, I think, has like 35. But these operations, it does that one thing based on the coordinates and the bit that you program in, right? It goes over and cuts that pocket, or it cuts that slot, or it cuts that chamfer, it does whatever based on, it tells the bit to go here, go down to here, move to here kind of thing, right? You're filling in the blanks. And that ability, I told the guy at Kipware, I see a big disconnect. You know, the CAD CAM is wonderful. I teach CAD CAM, I teach Vectric. I love it, right? But I'm right now writing my own G codes to do certain operations because I don't need a long Vectric G code to do a simple operation. And that's where conversational CAM software comes into play. And being able to have access to that, and anybody can go buy, you know, kipware.com and go buy your bundle package, right? It doesn't have to, you know, but it would be a package I'd like to be able to offer to digital carver customers when they buy CNCs, or if they need that. You know, I have customers that buy machines for production environments. There might be a little small printing shop, or it could be a, you know, a cabinet company or this or that. And to be able to do on the floor conversational CAM, you know, the operator just programs a few parameters and it writes the G code and they go carve their parts. Phenomenal, right? Cabinet cutting and that kind of thing. So everybody should get to experience it at some point in time, and you need no experience. You just need to be able to know how to take measurements. On my piece of stock, I need the bit from the XY 0 position. I need the bit to be able to move over 4 inches, make a cut 3/4 of an inch, and then move another, well, in this case, whatever that location is, for, let's say, call it 4 3/4, and then go another 3 inches. I need to be able to just fill in those blanks, and it's going to make those linear cuts, you know, based on those coordinates that I program in. I just need to be able to measure, right? All right. And I need to know the measurements of my design or my whatever. All right. So Brooks real quick says, only if you're using the bed as Z0. No. I'm assuming you're referring to, Brooks, if you're referring to on the coordinate systems and all, again. So let me clarify something really quickly. Let's say I have a job set up for the material surface to be Z0. Okay. My coordinate system, nothing changes in there, right? So I might set my coordinate system as X0, Y0 for, you know, like, let's say 38 inches on my table, 38 inches in, 15 inches up or whatever. That's my coordinate system number 1. And that's, you know, for there. Now the Z, that's X and Y. I just need to know where that is. As far as Z, I can set Z to 2 inches. I don't care. A Z could be left blank, because when I change to coordinate system number 2 and it moves over to that 0, 0 position, I now take my touch block and I touch off the Z on the top of my material and I run my toolpath. So nothing changes for me. But now if I have an automatic, like I have a sensor, I have what's called a fixed sensor on my CNC. JR, you do too. But that fixed sensor, the CNC knows exactly where that sensor is located. It's mounted on the table. So after JR and I, after we home our machine, and everybody else with, you know, homing with limit switches, you know, after we home our machine, JR could put in a bit. He could manually put in a 1/4 inch bit and then tell it to go measure the length of that bit. And it'll know exactly where to go to that sensor, and it'll be able to touch off and set the length of that bit, right? And so, you know, he can set his 0 just with a click of a button kind of deal. Or if he wanted to, he doesn't have to use the fixed sensor. He still has his mobile sensor, his little touch block. He can put that right down on the top of the material, hover his mouse over it and bring it down, touch off and up, and it'll set 0 for the top of the material, right? So there's multiple ways that you can set your 0. So Brooks, it doesn't have to be, just on the machine bed. But if you don't want to reset 0, if I set coordinate system 1 is my table for, say, Z0 is the tabletop, the machine bed, and coordinate system number 2, the jig surface is my machine bed, but that's actually 3/4 of an inch higher than my actual like wasteboard, right? So then my coordinate system would be X5, Y1, whatever that corner is, and then Z 0.75, right? So it knows that it's got to be up higher. So it's yeah, cool stuff. But yeah, And everybody, I really, really appreciate all of you hanging out with me this late. Hopefully, I don't know, this kind of went, the Planet CNC is, that's kind of, specific to Planet CNC, but coordinate systems, offsets, let's call it that. Because if you're talking to people in Mach 3 world, it's offsets. Planet CNC, it's called coordinate systems, but it's also offsets. But G54 through G56, right? So if I had a post processor and I created the toolpath in Vectric, like my Vectric toolpath, I could come up, let me make myself big just to show you this, because this is important. In Vectric, I learned how to do this. I created this, I calculated that toolpath, I saved the toolpath, but now over here, right at the in the header area, I could come over here and let's go push that down a line, and I could type in G59. Let's make it a capital G59. Now, when I say that, this toolpath now, when I hit start, the program is going to switch. The first thing it does, it's going to switch to the G59 coordinate system that I have set up, that offset number 6 or whatever, that location. And now that location is 0, 0, right? So it's going to work from that location on the table. This whole G code right here, it's going to be working from those coordinates. If I had this set to, if I programmed in, I manually changed this to G55, then whatever those offsets were, wherever that location is on the table, that offset location, when I hit start, it's working off that location of the table. It's going to move over and work off that location of the table. So I can literally assign my offset, manually type in my offset location in the header of my G code, because it always, that G code runs off that jig, and that's the jig runs off that offset location, right? So I can alter it to put in that location. So I don't manually have to go into my software and type in the MDI box, or I don't manually have to go into my software and go to machine coordinate system and select coordinate system number 4 or 3. When I hit start, it automatically reverts to that coordinate system, because that's the first in the header. That's the first line of G code. It lets the software know we're working off offsets G54. You know what I mean? So, all right. Cool stuff.
Very cool.
All right, everybody. I keep saying it, but we're going to say good night now. It's been a long night. And check out on your CNC machine. Look at your controller, whatever you have. Check out offsets. Right, G54 through G54 through 59. There's 6 locations, and as default, you can go more than that, but you have to look at your controller and what it does. Planet CNC, it's 59.1, 59.2, that kind of thing. But check those out. Figure out, like, hey, I have a certain arsenal of router bits at my disposal, but magnate.net is a great place to buy all kinds of cool ornamental milling profile bits. That's what they're referred to as, ornamental milling profile bits. Things like, rope twist bits and barley twist bits and OG bits and all these kind of cool profiles and stuff. Magnate's a great place, a great source for that. But any router bit, any profile, you can do profile-based carving, simplistic profile-based carving right out of Vectric. You're simply following a profile or whatever, a line, and it's based on the router bit that you're using. That's what it's gonna look like when it cuts. And check all that stuff out. And the last question that gets answered. So your G-code mod is the first actionable code. Yes. So in the header, so this is what our toolpath, this is what our G code looks like when we load our G code in Planet CNC. So when I come over here and go File, Open, and I open up that, bear with me a second. quick access. When I open up that toolpath, oh, it's not going to let me because I'm in a different profile. These are sample profiles. But when I open up that G-code, the very first line of G-code for us is G17. That's what you're going to see, G17. That lets the software know we're working in an XY plane on our table, not a XZ plane like on a rotary axis or a lathe or something like XY plane. So right above G17 is where I would put in my coordinate G-code, G54, 55, 56, 57, 58, 59, 59.1, whatever it is, right? And now, but in my CNC controller program, I need to have those offsets programmed in. So in the case of Mach 3, they have it's called offsets values or whatever, but it's like a little table, and it kind of records all your offsets. So you move your machine over to a location. If you type in G55 and you zero out that position right there, it's setting that coordinate system for that G55. If I move over here, I change to G56 and I zero out here, it just set that coordinate system for that location for G56. So you go in and you set your coordinates, and that keeps that little table. So whenever the G code calls up G55, it's reading off that table. And for Planet CNC, it's reading off of our coordinate system table. So we have a list of our offsets, and it keeps track of those offsets. So, and things. So it's pretty cool stuff. All right, everybody. And Mach 3 does it too, and it's just a different sheet. It looks different, and it's a different, they call it something different. Just look for offsets and things. All right, everybody. Y'all have a wonderful evening. JR, you have a wonderful evening. But we'll catch you at another time. Thanks, everyone.